What's up guys, welcome back to the channel. Today, as you can see on this video, we'll be solving this previous question paper that you see here. As you can see, this is a mathematics N4 previous question paper which was actually written on the 20th of November 2024. It was an X paper and it took about 3 hours to be written. Now on this video, we're gonna start with question 1, and then we do question 2, question 3, question 4, and question 5. So I'm gonna leave the timestamps so that you can able to watch the specific question that you would like to watch, just in case you don't want to watch these videos in a sequence order. Now before I start though, I just like to say thank you very much guys for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel because I've done lots and lots of videos based on mathematics and also previous question papers like this one. All right guys, so on this particular video though, we're gonna start with question 1, and also this question 1 we're gonna leave timestamps if you want to see 1.1, 1.2, 1.3, or whatever the case, as long as you don't want to watch this question in a sequence order. Now let's look at question 1 and let's see if we can able to solve it. Right guys, as you can see, here is our question 1. So question 1 consists of 1.1, 1.2.1, 1.2.2, and 1.3. So it actually has 1, 2, 3, 4 questions. Now we're gonna start with this one here, which is 1.1, where they want us to draw this neat graph of y is equaling to 2e to the power of 3x. So I'm gonna copy this question and I'm gonna paste it where there's space and we start solving it. All right guys, as you can see, here is our 1.1. Now they state that we should draw a neat graph of y is equaling to 2e to the power of 3x. Now as you can see, this graph here is an exponential graph because our x is an exponent. So now how do you draw an exponential graph? The easiest way of drawing an exponential graph is to use the table method. Now I'm gonna draw the table here and insert the values for x so that we can get the values for y. Alright guys, as you can see, this is our table. Now it's time for me to insert the x values. Now you can insert negative x values and positive x values. Don't forget to also insert 0. I would say to you guys, don't insert big numbers because we have the x coefficient there, which is 3. If you insert big numbers, you will get very huge numbers for y. But you can insert any number as long as you understand how to draw this graph. So I'm going to use negative 0, 2 for x and also negative 0, 1 on the negative axis of x, then it's 0. And in the positive, I'm just going to use 0, 1 and 0, 2 on the x-axis. Now on the y-axis, it will depend when I substitute our x, what is going to be our value. Remember guys, you can use any number as long as you can able to draw. So I would say to you, use the smaller numbers for x so that your graph cannot be big or give you big y values. All right, let's start substituting. So wherever there is x, we're going to substitute with the x values in the table there. Now let's start when x is negative 0, 2. Now if you punch this on a calculator, your answer is going to be 1, 1. So meaning when x is negative 0, 2, your y is 1, y. And then let's put another value there. Now when x is negative 0, 1, what is our y? Now our y is going to be 1, 5 approximately, right? Now when it's 0, our y is going to be 2. There we go. Now what about when it's 0, 1, the positive side? Our y is going to be approximately 2, 7. When it's 0, 2, our y is going to be 3, 6. So this is basically what our table look like? So we're going to use the values on this table to draw our exponential graph. So let me first draw the Cartesian plane and let's start plotting the graph. All right, as you can see here, guys, we have the following values on our Cartesian plane. Now it's time for us to just plot the graph. So let's start with the first point here, where x is negative 0, 2, which is this one here. You just take a ruler, you draw a vertical line like that, where x is negative 0, 2. What is your y? So your y is going to be 1.1. So we have 1 here. So above there, a little bit above there is going to be 1.1. So wherever they meet here, this is your point. Right. Now, what about the second point where x is negative 0, 1? Now we know that x is negative 0, 1 here. So you draw a line that is vertical to that point. All right, and then our y is going to be positive 1,5. So 1,5 is 1.5. So if we have 1 here, half is going to be between 2 and 1 on a y-axis. So you draw a line again as it touches this. This is your point there. Now when x is 0, remember x is 0 on a y-axis, and then y is going to be 2. So that is an intersection, which is 0 and 2. And then when x is positive 0, 1, which is this side on the positive side of the x-axis, and then our y is going to be 2,7. Now, so 2,7, when you look on the y-axis, is going to be somewhere almost close to 3. So we can put it here, right? And then you do it then. So when our x is 0, 2, our y is going to be 3,6. Let's look at x on the positive side on 0, 2. Draw the line there, vertical to that. Obviously, you must use a ruler. And then your y is going to be 3,6. So if you look at y-axis on the positive side, 3 is our 3 here, 3,6 almost in the middle between 4 and 3. So you're going to lean more into 4. So you're going to be drawing a line like this, and then as it intersect there, this is going to be your point. Now remember, the exponential graph, it looks like this, right? And the asymptote on x-axis, or it looks like that. As you can see, our graph here is going to asymptote on the negative side of x-axis. So you start connecting. Now let's start connecting. I am just going to do this. All right, guys, as you can see, this graph here, it has to asymptote on the negative side of x-axis, just in case you didn't know, right? It never, ever crosses the x-axis. It asymptotes on it. On the positive side of axis, it grows. As you can see, it's going to grow and to infinity. So guys, basically, this is our graph here. But the most important things that you must show here is the intercept. So the intercept here, guys, it's actually 0 and our y is 2. So even if you didn't show these other points, as long as the graph has this shape and also you show this y-intercept, then you are correct for this graph. I hope you guys managed to understand how to draw this graph. Just in case you didn't understand, do not forget to leave a comment in the comment section. I'll try to answer you to my level best. But just in case you manage to understand how to draw this graph, you can always leave a like, and also if you haven't subscribed, subscribe to the channel. Right, guys, so we are done with question 1.1. We are going to do question 1.2. All right, guys, so let's look at 1.2. As you can see, 1.2 consists of two questions, which is 1.2.1, 1.2.2. So let's start with 1.2.1, where they want us to draw a neat graph of y is equal to negative 2 over 3 x minus 2. So I'm going to copy this question that you see here, paste it where there is space, and let's try to draw this graph. So guys, let's look at 1.2.1. As you can see, this here, guys, it's a graph of y is equal to negative 2 over 3 x minus 2. Guys, as you can see, this is actually the straight line graph. We have our y, we have our gradient, we have our x, and we also have our constant. Our gradient, which is negative 2 over 3, and our constant, which is negative 2. Now, guys, how do you draw a straight line graph? So the method that we're going to use here is the simplest method ever. We're going to use the intercept method, where we only find the intercept of the straight line graph. Remember, in order for you to draw a straight line graph, you just need to have 2 points. So those intercepts, they're going to give us 2 points, and then we connect, and then we have a straight line graph. So let's start. Whenever you use this method, you either make x or y 0. So let's start when x is equaling to 0. What is our y? All right. So when we use this method, we are basically saying that on the original equation, wherever there is x, we substitute with 0. So we know that y is equal to negative 2 over 3 multiplied by x. But wherever there is x, we substitute with 0 minus 2. Now, this is going to give us y is equaling to negative 2, because anything multiplied by 0, it's 0. So you're going to be left with negative 2. So we can say point A is 0 and y is negative 2. So we have 1 point. Now, the second point, we can also use the similar strategy, but this time we can say, let me just draw a line here. When y is 0, what is x? Right. So this time around, we make y 0. So wherever there is y on the original formula, we put 0 is equaling to negative 2 over 3 x minus 2. So what we do here, we're going to transpose. So how about we transpose this term, negative 2 over 3 multiplied by x, to the left-hand side. Now, when you do that, when you take this to the left-hand side, this 2 is going to become positive over 3, and then x. All this is equaling to negative 2. Right. And then from here, what do? We multiply by 3 throughout to get rid of this 3 here. So if you multiply by 3 both sides, you're going to be left with 2x. And this side here, we're going to be left with negative 6. Then we start dividing by 2 throughout. If you divide by 2, this is going to be x. And that is going to be negative 3. So we can say point B is when x is negative 3, then y is going to be 0. So basically, these are the 2 points that we needed in order for us to draw the straight line graph. So let's draw the Cartesian plane and let's start plotting the graph. Right, so here is our Cartesian plane, guys. Please make sure that when you draw your Cartesian plane, you indicate your y and your x, and also show the negative side of the x and the negative side of y. Now let's look at point A. Point A states that when x is 0, y is negative 2. So x is 0 on the y-axis. So our y is going to be negative 2 here. There we go. And in point B, state that when x is negative 3, y is 0. By the way, y is also 0 on the x-axis. So meaning our y is going to be here on the x-axis and our x is going to be negative 3. So from there, we just connect these 2 points. Right, so let's connect these 2 points, guys. Right, so here is our graph here. So you can name this graph y is equaling to negative 2 over 3 x minus 2. So this is our straight line graph. Some of you guys don't like to draw this. It's fine as long as you show these points here. If you don't like to add this other points, as long as you show these points here, that this point here, which is point B, it's negative 3 and y is 0. And then here, and then negative 2. So you can also show that as well without showing these numbers here. It's still fine. But I would prefer you guys to draw everything so that everyone can see how do you get to this point? Guys, basically this is how you draw the straight line graph. You only need 2 points. In this case, it's going to be point A and point B, and then from there you just connect these 2 points, and then you have your straight line graph. Guys, I hope you find it easy to draw the straight line graph. If it just so happen that you don't understand how I drew this graph, do not forget to leave a comment in the comment section. I'll try to help you to my level best. If it so happen that you manage to understand, or this helps you to understand, you can like the video, and if you haven't subscribed to the channel, subscribe to the channel. All right guys, we are done with 1.2.1. now it's time for us to do 1.2.2. so let's look at 1.2.2. what is it that they are asking for? The question is, the graph y is equal to negative 2 over 3x minus 2, a function or a relation. So you have to choose between the two. If this question is a continuation from question 1.2.1, this here, the one that we did earlier. So we need to go to the graph so that I can explain to you guys what is the relation and also what is a function. All right guys, so with 1.2.2, they want us to find out what is a function and relation. I'll try to explain to my level best. Now, there are two ways of knowing how to distinguish between the two. So let's start with the function. A function, how do you identify whether a graph is a function or a relation? It's very simple. Now, let's start with the simplest strategy ever. One of the strategies or one of the methods that you can use to distinguish, it's when your graph, for example, we have an x-axis, we have a y-axis. It's when your graph cuts the y-intercept once. So as you can see, this is a straight line graph. How many times does it cut the y-intercept? Only once. So if it cuts the y-intercept once, it means it's a function. As you can see, this graph here only cuts here, guys, only here. It doesn't cut anywhere else. If you continue with this graph, it's going to cut them. Another example, let's use a parabola. For example, let's say we have a parabola that goes like this, right? As you can see, this parabola here, it only cuts this y-intercept once. Then it can continue and expand. It will never ever gonna cut anywhere else. So it cuts the y-intercept once. So when it's like that, this is a method that you can use to say this is a function, right? Now, another method that we're gonna use, it's gonna be, let me just erase here. Now this method here that we're gonna use, guys, let me first draw the graph. This time let's draw it this way, right? Another method is when you use the x value to find the y value. Now if the x value gives you one value of y, then it's a function. Basically, if one x value gives you one y value, then it's a function. Here's what I mean. If we have, let's say this is 0.3 for x, and then if we draw a vertical line on any x value, but this time we're going to use 3, for example, we draw a vertical line there that passes on x on the graph there, here, it's going to give us one y value. In this case, let's just say negative 2, meaning now 3, which is x, it's giving us negative 2. We call this method 1-to-1. So the x value is going to give you one y value. Yes, there's no any other x value that is going to give us negative 2. So it's only this 3 that is going to give us negative 2. So this method here, we call it 1-to-1. Now let's make an example with a parabola. So let me just do a parabola graph like this, for example. There we go, right? Now if we have a parabola like this one, let's just say this is negative 1. Let's use x as a negative 1. Now how do we do it? Wherever there is x, you just draw a line that is vertical here, and then wherever it intersects them, as you can see, it's going to intersect them, the value that you're going to get here is going to be a y value. Now at this point, let's say maybe y is 3, right? There's nowhere else where this negative 1 is going to give you a different value. So In this case now, the negative 1 of x is going to give you positive 3. So this is 1, 2, 1, right? Any x value on this graph is going to give you one y value. Any x value. If you connect at any point here, there's going to be one y value and one x value. So this is another method that you can use to identify or to distinguish between function and a relation. I hope you guys managed to understand this one, guys. Right, now let's see how do we able to see if it's a relation or not. Now, when it's a relation, let me just show you another trick. This is the simplest trick. When you have a graph that cuts y twice, it's a relation. For example, if you have a graph like this one here, which is a circle, it cuts how many times? It cuts y how many times? It cuts y 2 times. So if it cuts it 2 times or more, just know that it's a relation. It cuts it here and also cuts it there. So it means it's a relation. Any graph that cuts y-axis twice or more, just know it's a relation. This is the simplest of them all. Another graph like that, which is a relation, could be a semicircle like this one. It's going to cut at this point here and also at that point. As you can see, it cuts once and also cuts the y-axis twice. So this means this is a relation. I hope you guys can able to see this. Now how about the other method? Because there are two methods of distinguishing the relation and function as well. Now this one, it's 1 to 2 or 1 to more, but basically it's 1 to 2. So let me show you that method that I was using. Now, for example, on a circle, right, if any x value, let's say this is 2, that gives you 2 or more y values in a graph, just know that it's a relation. So just know that the graph is a relation. For example, let's use this two. If we were to draw a vertical line here going downwards there, this point here, our y is going to be positive y, and at this point here our y is going to be negative y. As you can see, x, which is the x value, gives you 2 y values. So this is 1 is to 2. Actually, one x value gives you 2 y values. So just know, if you come across that, just know that this is a relation. Now let's use another example of a graph, right? Let's say we have a graph like this, a hyperbola. Let's say we have a hyperbola. As you can see, now the hyperbola is no longer cutting at y. Which one is this? Is this a relation or is this a function? Right? How do you do it? It's very simple. Look, you just take any x value. Let's say this is positive 2. If it cuts the graph twice, just know that it's going to be a relation. If it cuts once, it's going to be a function. So let's look at this. If you draw a vertical line like this cuts only once. So it means these two gives you one y value on this graph. So it's 1 is to 1, right? But then what if we have a graph like this one, which is more like a central hyperbola? So how are we going to do this? Look, it doesn't matter, guys. If I take any value here, let's say this is 3. If I draw a vertical line and it cuts twice on this, it means that this 3 gives me 2 y values on the graph, because this is going to be a positive y and that is going to be a negative y. So this becomes what? A relation. Remember, this is 1 is to 2. There we go. So that's how you do it, guys. I hope you managed to understand this. If you didn't manage to understand, you can leave a comment and I'll try to answer you to my level best. But then, if you to look at the graph that we just drew now, it cuts how many times? It cuts the y-intercept how many times? It only cuts it once here. So this is a function. Now, if we use the other method, you can take any x value and you draw a vertical line. You will see you're going to only have one y value. For example, let's just take this negative 1. So if you draw a vertical line on a negative 1 like that, on the graph is going to cut or is going to intercept only once. Now it means that -1 is going to give you whatever y is here. So we can say y maybe is -1, 5. So -1 gives you -1, 5 of y. So this is 1 into 1. It's 1 into 1. So this -1 is going to give you only this y value here. So guys, this makes it a function. So there are two ways of doing this. So rather use the one whereby it intercepts the y value once to say it's a function. If it intersects twice, you say it's a relation. The 1-to-1 and 1-to-2, it needs you to understand better. But I hope you guys managed to understand this one. I will make a video deeper on this, so I'll try to explain it to my level best on that video. But anyway guys, if this helps you to understand, do not forget to like, share, and also comment on the comment section. Guys, we are done with 1.2.2. Now it's time for us to do the last question, which is 1.3. Right, let's look at 1.3. As you can see, 1.3, the one has to draw a neat graph of an inverse of x is equaling to 1/5 natural log y. So I'm going to copy this question, paste it where there is space, and try to draw it. All right, let's look at 1.3. Now this question here, it says draw a neat graph of an inverse of x is equaling to 1/5 natural log y. Now before you draw this graph, guys, you need to write the inverse equation of this graph here. So the inverse is just swap x and y. So wherever there is x, you put y is equaling to 1/5 natural log, and then wherever there is y, we put x. So you swap your x and y. There we go. So that's what you do. So from now on, we're going to use this inverse equation to draw or plot our graph. But then the method that you're going to use to plot our graph, it's easier to use the table method. So I'm going to sketch the table here and insert the values. And then from there, we're going to start plotting the graph. All right, guys, as you can see, we have our table here. So before I insert the x values, I need to mention something about the natural log graph or the log graphs. What you need to know is the log graphs, they tend to asymptote at y-axis. Here's what I mean. Meaning the log graphs, they look like this, the shape of the log graph. Some will look like that. Others will look like this, going this way. And then others will be on the other side, and others will be looking this way on the other side. What I'm trying to highlight here is that these log graphs, they never ever touch the y-axis. It means that it asymptotes. So for this specific graph that we're doing here, it's going to look like this one here. So it's going to asymptote on the y-axis, and also it only has positive x values, meaning on a table, you can only include positive x values on this table and rather include very small numbers of those x values. Now, also, you cannot have x as 0 because it doesn't touch the y-axis. So if x is 0, you know that x is 0 on a y-axis. So I'll start with 0, 5. And then I continue with 1, 2, and 3. I think these points here, they will be enough. This will give us 4 points. So from here, what you do is we're going to start substituting these x values to this part here of the equation. So let's start. So when x is 0, 5, what is our y? Now, if you put this on your calculator, you'll have negative 0.14 approximately, right? And then we go to the next point. When x is 1, what is our y? So if you put that on the calculator, our y is going to be 0. Right, we continue. When x is 2, what is our y? It's going to be 0.15. 4. This time around, this is positive. The last point here, when x is 3, what is our y? It's going to be 0, 2, 2. As you can see now, we have all the points. Now we can start sketching the graph. So let me erase this. Right, now that we managed to draw our Cartesian plane, it's time for us now to plot the graph. But before we plot the graph, I'd just like to mention something about the scales here. Look at the y-axis. I decided to use 0, 1 to 0, 2, 0, 3. So the scale is 0, 1. Now, the reason why is because when I look at the y values here on this table, I can see it's 0, 1 and 0, 2 and so on and so on. So we can use that scale on the y-axis. And x-axis, you can use the normal numbers, which is 1, 2, 3, 4, 5. Now it's time for us. Let's sketch the graph. Now let's look at the first point. The first point says when x is 0, 5, y is negative 0, 14. So 0, 5 for x obviously is going to be between 0 and 1. So it's in the middle. It's half of 1. So it's going to be there. So you take your ruler, you draw a line that is going downwards like that. There we go. And then for y coordinate, which is negative 0, 14, you go to the y-axis and you look on the negative side of y-axis. Now 1,14, it's somewhere above 0, 1. Okay, somewhere here. So it could be in the middle because 1,14 is very close. Is very close to the middle of 0, 1 and 0, 2. So we can say somewhere there, right? And then here. So at this point where these two lines that you just drew, where they intersect, that is your point. Now we are done with this point. Now let's go to point number 2. When x is 1 or y is 0. So this point here, it's exactly there because x is 1 there and y is 0 there. All right, so the third point where x is 2, our y is going to be positive 0, 14. So if x is 2, we take a ruler again, we draw a line vertical that is going upwards because we're going to have a positive y. And then our y is going to be 0, 14. So 0, 1 is this point here. 0, 14 is going to be somewhere almost in the middle between 0, 1 and 0, 2. So somewhere there, you draw a line that is horizontal. And then wherever these lines intersect, you put a point there. And then the last point where x is 3 and then y is 0, 2. Again, you do the same thing. You take a ruler, you draw a line that is passing on 3 upwards on a vertical. And then you look for 0, 22 on your y-axis. So 0, 22, it's supposed to be a little bit above 0, 2 because this is 0, 2. Maybe to make it 2, you have to go a bit above. So from here, and then you draw a line that is horizontal, right? And then if the line intersects with that, now that becomes the point. As you can see now, we have all the points. It's time for us to just connect the lines. So let's connect the lines. Okay, as you can see now, this is our graph. Now this graph, like I said, the log graphs, they always asymptote on the y-axis. So this graph will continue and asymptote towards the y-axis. And then on the other side, on the first quadrant, is going to keep on growing exponentially. All right, so as you can see, guys, this is how you actually draw this graph. Now, what is most important here is this intercept of x here, which is 1 and 0. Please indicate it because it's very important. And also the shape of this graph is also very, very important. And the rest is not really that important. But for the purpose of understanding, make sure that you show everything that you need to show in this graph. All right, guys, I hope this helped you to understand how to draw an inverse graph of a natural log. This is actually how it looks like. Just in case you didn't understand, you can leave a comment in the comment section where you ask a question and I'll try to answer you to my level best. If this part of the video helps you to understand how to draw an inverse graph of a natural log, do not forget to like the videos. If also you haven't subscribed to the channel, subscribe to the channel. Guys, at the end of this video, there will be a playlist of this question paper that you are watching, which consists of question 2 to question 5. And then also, if you really want to watch other questions that I've already solved, I will leave a playlist next to this one here as well. Thank you very much, guys, for watching. Till next time, cheers.